Welcome to MOVIMOT and Field Distributors Basic and Intermediate Training. This is Session 1. In our last session, I introduced the course and gave you a general idea of what to expect. We're now ready to move into the course proper. And as I explained last time, the first part of this class, Sessions 1 through 8, deal with MOVIMOTs. We're going to learn about MOVIMOT in this session. We're going to introduce some of the basic concepts that will help you understand it and just make it make sense. Before we do that, however, I would like to go over the knowledge and skills goals for this class so you know what you're going to be learning and what you'll come away with. First of all, I'm going to help you understand how to identify MOVIMOT models and nomenclature. Nomenclature is the SEW codes that identify the features of a product. It can be rather mystifying if it hasn't been explained to you, so I'm going to go over it and make it clear. We're going to talk about control and communications modes so you understand what it takes to operate a MOVIMOT. You're going to recognize some of the common accessories that go with MOVIMOTs and expand their capabilities. We're going to talk about the conduit box connection so you know how to wire one up. We'll work with the control head switches that configure the MOVIMOT. You'll learn to set up your MOVIMOT in Easy Mode, which is the mode that most people use when they configure their MOVIMOTs. Easy Mode is nice because you just need a few simple hand tools to configure the MOVIMOT. You'll then learn to control the MOVIMOT in Easy Mode, which is equally simple. We'll discuss how to interpret error codes so you know what's going on if your MOVIMOT faults. We'll learn to connect using the DBG60 keypad, which can be handy for certain situations. We'll also learn to connect to PC running MoviTools Motion Studio using a USB interface, which gives you a lot more power. And then finally, we'll learn to shift into MOVIMOT's Expert Mode, where you can control it by setting parameters, which unlocks a lot more capability than Easy Mode has. I'm also going to point out the documentation that's available so you can learn more about your MOVIMOT. There are two manuals, both available in PDF format from SEW Eurodrive's website, and I've included a link in the description below. The Compact Operating Instructions manual is sort of the abridged edition, which contains just the essentials. If you want to know absolutely everything, look at the Operating Instructions manual, which is quite a bit longer. All right, before we discuss MOVIMOT proper, we need to talk about VFDs, variable frequency drives, because that's what a MOVIMOT is. It's important you understand what a VFD is and how it works, because that will make setting up your MOVIMOT make more sense. Before we dive into the details of how VFDs operate, I probably should make a point about terminology. The terms variable frequency drive, VFD, and inverter are all equivalent terms, and I will use them interchangeably in this class. All right, let's learn the parts of a VFD. All VFDs have the same basic components. VFDs are actually relatively simple in some senses of the word, although they do some very complex things internally, but understanding how they work isn't really that hard. A VFD begins by getting a source of electricity. We call this the line in. This can be three-phase alternating current, which is very common in industrial settings, although some VFDs will accept ordinary single-phase AC. MOVIMOT, by the way, always works on three-phase, so be aware of that. The alternating current is brought into the VFD. The first thing that happens is it's converted to direct current, DC, by a rectifier. The rectifier converts it to a kind of pulsating DC. The pulsating DC is then fed into a series of filters. The purpose of the filter network is to smooth the DC, and it will look something like this. If you connected an oscilloscope up to the VFD at this stage, you would see kind of a ripply flat line. That is direct current. It's usually a pretty high voltage, often around 700 volts or more. Some VFDs have an external connection where this voltage is available. It's called the DC link. MOVIMOT doesn't. However, there are places where you can monitor it, and it goes under the name DC link, so be aware that's what we're talking about, the rectified and filtered DC. The DC is then fed into three fairly hefty transistors. These are called IGBTs, which stands for Insulated Gate Bipolar Transistor. Think of these as high-speed electronic switches that can turn on and off thousands of times a second. The IGBTs are controlled by a microcontroller that's sort of like a little computer, and it pulses them on and off in various patterns to create what I call a synthetic alternating current. It looks something like this. If you connected an oscilloscope up to the output of the VFD, you'd see something sort of like this. And you might think, boy, that doesn't look like alternating current. Alternating current is usually a sine wave. Well, yes, that's true. However, from the motor's point of view, it is a sine wave. You may wonder, how does that work? Well, let me explain that in a little more detail, how we create the synthetic AC. We use a technique called pulse width modulation, or PWM. We basically take the DC and turn it on and off very quickly, but for different periods of time. By varying the width of the pulses, the VFD produces what looks like a sine wave as far as the motor's concerned. And the nice thing is you can create basically almost any voltage and frequency you want. Now let me show you how this works. If you look at these pulses, you notice that they vary in how wide they are. This pulse here is very skinny, so as far as the motor's concerned, that looks like a low voltage. This pulse is a little wider. In fact, it's on and off for equal periods of time. That looks like a medium voltage to the motor. And this pulse here is on most of the time, so it's quite wide. That looks like a higher voltage. What the motor winds up seeing actually looks like this, which is in fact a sine wave. So VFDs are rather clever. They do some very sophisticated things. It's a rather elegant solution to motor control. Let me give you a big idea here that's crucial that you understand. A VFD controls the motor's speed by varying the synthetic AC's frequency supplied to the motor. Most AC motors' speeds are determined not by the voltage you apply, but by the frequency of the alternating current, how many times it cycles per second. In fact, there's even an equation which will tell you the relationship between frequency and speed. You take 120, you multiply it by the frequency coming into the motor, and you divide it by the number of poles in the motor. Motors typically have 2, 4, 6, or 8 poles. 4-pole is probably the most popular. You put that information into the equation, you'll get the speed. So let me give you an example here. Let's say we have a 4-pole motor and we just send 60 hertz alternating current into it. You take 120 times 60 hertz, divide by 4 poles, and you get about 1800 RPM. Pretty simple. The VFD basically just controls the motor's speed by ramping the frequency up and down. It does a few other things as well, but we won't talk about those here. So pretty clever, nifty idea. All right, enough theory, let's talk about MOVIMOT. We're going to start by looking at the models and nomenclature of MOVIMOT, so when you see one on a shop floor, on a factory line, you'll know exactly what you're looking at. You can look at the nameplate and say, I know what that MOVIMOT is and what it does. All right, models. MOVIMOT comes in 2 distinct sizes and 8 different power ratings. So this is the smaller size, and you can see it's available in 5 power ratings. We have model MM03 through model MM15. They range from 0.37 kilowatts to 1.5. In the US, you probably think of motor power in terms of horsepower. That's approximately half a horsepower up to 2 horsepower. So the smaller MOVIMOT can handle anywhere from fractional horsepower up to 2. And those are the models that are available. Now the second model you can tell is a little bigger. And if you look at it, the heat sink is the way to tell them apart, those pointy rod-like things that dissipate heat. There are more of them on the bigger MOVIMOT because it generates more heat. There are 3 models of it, MM22 through MM40. This goes from 2.2 kilowatts to 4, which is 3 horsepower up to 5.4. That's where MOVIMOT tops out. So this can cover quite a few different kinds of motors and different kinds of applications. By the way, you probably noticed that the number after the MM is the approximate power in kilowatts. That's no coincidence, that's intentional. So just by looking at that number, you know the kilowatt rating approximately. MOVIMOT is available by default in IP54, but it's also available in 55, 65, and 66 upon request. You may be wondering, what's IP? IP stands for ingress protection, and there's a red term, by the way. It indicates how particles and liquids can get into an enclosure and how resistant it is to things coming into it. The first number in an IP rating indicates its particle resistance, and the second number is liquid resistance. As you probably can guess, the bigger the number, the more resistant it is. IP54 will keep out most dust, and it will keep out splashes of water. So that will cover a lot of applications. But if you really need more resistance, get IP66. That is totally dust-proof, and you can spray it with jets of water and they won't go in. In other words, washdown type applications. So IP ratings are very important in many applications if you're not running in just a clean, dry environment. MOVIMOT supports 2 motor control modes, one called VF, which will control just about any kind of motor. It's a very simple control mode. But it has a much more sophisticated motor control mode called VFC, which stands for voltage flux control. VFC is better when you're using SEW brand motors because it will get the most out of them and control them in the most effective way possible. All MOVIMOTs have 3 digital inputs and 1 relay contact as a digital output. So some basic digital I/O is present in there. If you need more, you would have to add a field distributor, which we'll talk about later in the course. It also includes an RS-485 serial communications port, which can be used to connect MOVIMOTs up to a PLC or other industrial computer or controller. This method can be used to control a series of MOVIMOTs, and you can actually control them more finely and more specifically if you use RS-485. We'll talk about that later. So that is a feature that's available if you need it. There's also brake control if your motor has a brake, and there is the ability to monitor the motor and protect it from overheating. There are also many expansion options, so you can add things to the basic MOVIMOT to make it do extra things. We will certainly cover those. Also, as I mentioned before, MOVIMOT can be mounted either directly onto the motor, or it can be mounted nearby on a special mounting plate with a short cable connecting it to the motor's conduit box. It just depends what your application needs. Now, nomenclature. That's the SEW code words that identify features on a MOVIMOT. You'll see this on the MOVIMOT's nameplate, and if you wonder what those codes mean, well, you'll know in just a couple minutes. MOVIMOT happily has a very simple nomenclature that's easy to understand. So here's the typical MOVIMOT nomenclature that you'll find on a nameplate, MM15D-503-00. What does that mean? Well, let's break it down. MM just means MOVIMOT. 1.5 is the approximate output power in kilowatts. You have to insert a mental decimal point between the 2 digits, so this is a 1.5 kilowatt MOVIMOT. D means it's version D. That's the current version of MOVIMOT. There was a C version, a B, and an A, which are discontinued. D is what you'll see on a current one. Then the 5 and 0 indicates the connection voltage. There are 2 choices here. This one, because it has 5-0, operates between 380 and 500 volts AC. If you see a 2-3, it means it operates on 200 to 240 volts AC. 3 means it's 3-phase. There are no single-phase MOVIMOTs. They are all 3-phase. And 0 just means it's the standard edition. Okay, that is it. Understanding MOVIMOT nomenclature is pretty trivial. So there you go. I told you it was simple. Let's talk about the control and communications options that are available with MOVIMOT. First of all, control modes. How can you control your MOVIMOT? Well, there are a wide range of control modes available. The most common is binary control, where you use digital signals to tell the motor what to do. You could do this with just simple switches, or you could do it with some kind of industrial computer or a PLC with digital outputs or relay contact outputs. That can control MOVIMOT just by sending a few binary signals. In this mode, you use the 3 digital inputs and the relay contact. This gives you clockwise and counterclockwise control, so you have full direction control, and you can select between 2 fixed speeds. We call these set points. They're called F1 and F2. So you can choose between the 2 speeds to run the motor. There's also what's called a fixed ramp. Ramp is how fast the motor accelerates and decelerates, and there's a programmable ramp that you set, and it is fixed once you set it. And the relay contact just provides status information. You don't have to use it, but it does tell you what the drive is doing. So that is kind of the simple control mode. We'll be covering that in this class, of course. But if you need more sophisticated control, you can shift to RS-485 control, or you can use a field distributor and use field bus control. They actually work very similarly, so I'm covering them together. In this situation, you connect an industrial computer, controller, or PLC up to either the RS-485 interface or to a field bus, and you send process data words over them. So you use the interface and you send process data words across the field bus or the RS-485 interface, and that tells the MOVIMOT what to do. This gives you actually more control. It's more powerful than binary control. You have very flexible speed control and ramp. You also get more detailed status information, and you can do more with the brake. You have more elaborate brake control as well if your motors have brakes. So we'll be discussing all of this as we go through the course, and you can take whatever is useful to your application. All right, moving on to communication. How does MOVIMOT interact? Well, except for the simple binary control, which I've mentioned already, all MOVIMOT communications and control works through its RS-485 interface. It's kind of like this. You have some kind of master device like a PLC or an industrial controller, and you have multiple MOVIMOTs out there, each with a unique address that identifies it. So that's a number between 1 and 15. And then you have a twisted pair cable, two wires twisted around each other. They're called RS plus and RS minus, and they connect up to the RS-485 interface on each MOVIMOT and on the PLC. The PLC then sends commands over the RS-485 network. The MOVIMOT knows it belongs to it if the PLC uses its unique address. So it can address each MOVIMOT individually. So this is actually very powerful, but also relatively simple. So that is one style of communication. There's also another style of communication that also uses the RS-485 interface. There are some accessories you can buy with MOVIMOT, like this gadget. This is called the set point adjuster, and it can control multiple MOVIMOTs over an RS-485 network. What you do is you set them all to the same address, you set them to 1, and the set point adjuster controls their speeds. So this is something you would do if you wanted to run multiple MOVIMOTs together all at the same speed. You just use those little up-down buttons on the set point adjuster, and all the MOVIMOTs respond. Another choice is to use something called the set point converter, and it too can control multiple MOVIMOTs using a voltage. So if you want to have analog control where a variable voltage controls the speed, you can feed that into the set point converter. It sends commands over the RS-485 network to each MOVIMOT. Notice again, they're all on the same address, and they will all respond together. So that is another choice. And then finally, the most sophisticated, you can put a field distributor on each MOVIMOT, which will then allow them to be connected up to an industrial network. When you use the field distributors, you set the address of each MOVIMOT to 1, because all it does is it talks to the field distributor. It doesn't talk to anything else, and so the field distributor wants to talk to it on address 1. But the field distributors are totally independent of each other. They are connected up to a standard field bus, and a PLC can address each field distributor individually and control each MOVIMOT individually. Think of the field bus interface sort of like a gateway. It converts field bus traffic to and from RS-485. We'll be talking about this more in detail later. Now, let's talk about some of the options and accessories you can get with MOVIMOT to expand it and extend its capabilities. There are quite a few of these. We'll just skim through these rapidly. We'll start with power options. It's very important to understand that MOVIMOT requires 24 volts DC to operate. It cannot derive this low voltage for its electronics directly from the high voltage power that powers the motors. You must give it some kind of power supply. Now, if you have 24 volts DC available in your plant already, you can just connect it up to the MOVIMOT, and that takes care of it. However, if you want to derive power from the high voltage line, what you can do is you can add an accessory power supply. For example, you can add this one here, the 24 volt MLU11A or 21A. This will derive 24 volts from the high voltage motor power, and it will feed it into the MOVIMOT. This mounts externally on the MOVIMOT's conduit box. There's also an internal version, the MLU13A. The reason we offer these is because if you've got a lot of accessories, there may not be room in the conduit box for the internal one. So we give you an internal and an external. There's also one that includes a set point adjuster built in. So this is a power supply and a set point adjuster all in one. If you need that feature to electronically control the motor speed, you can get this one. There's also a line filter that cleans up power and ensures compliance with electromagnetic emission. These are the power options available for MOVIMOT. There are also some additional control options available. You can get the remote set point adjuster. I've shown you this. It can control a single MOVIMOT or a whole network of them. There's also a diagnostic unit. It looks just the same, but it shows error codes. It's not used for control. It's used for status. There is a rotary dial which mounts on top of the MOVIMOT. There's a plug you remove. You can see there's a numbered dial underneath, and you screw the rotary dial onto it. It engages with it. And this allows you just to manually control the speed by turning the handle between 0 and 10. You may use that, for example, if you're using a MOVIMOT to replace a mechanical variable speed drive. And then there's that set point converter that converts an analog voltage into commands that will control either one or multiple MOVIMOTs. So these are the control choices that are available to you. If you have questions about them, contact your SEW Eurodrive representative, district sales manager, or field engineer, and they'll be glad to explain these in more detail. All right, let's talk about braking options. There are actually quite a few of these, and it can be a little bit complicated, so I'm going to try to disentangle it and make it clear what options you have. If you have a motor equipped with a brake, then the MOVIMOT may be able to control it directly. The MOVIMOT can directly control a BE-type brake. In that case, you wouldn't need anything extra. You would just connect the brake up to the MOVIMOT and all would be well. But what if you need some extra features? For example, a brake that engages or disengages more rapidly than usual. Can that be accommodated? Or what if you have a low voltage brake, such as a 24-volt brake? Well, happily, there are options for all of these, but you'll need to add a brake controller. There are 3 choices available: the BEM, the BES, and the URM. The BEM and the URM accelerate brake action. The BES is for a 24-volt brake. So you would need to add these if you needed any of those features. Now, what if you have a motor that doesn't have a brake? Do you need anything extra? And the answer is yes, you do. And that's because of something called regenerative energy. If you stop a motor by cutting its power, but the load keeps it turning, the motor actually becomes a generator. And during that period where it's coasting down on the momentum of its load, it's putting energy back into the MOVIMOT, which could actually be destructive. That energy is called regenerative energy, and it needs to be transferred somewhere else and dissipated. The way you typically do that is by taking a resistor, passing the current through it, converting that energy into heat, and then just dissipating it to the environment. So if you have a MOVIMOT without a brake, you're going to have to add some kind of brake resistor. Now, there are a number of choices available. The ones shown here are all external brake resistors that mount outside the MOVIMOT. There are 2 internal choices, which I haven't shown here, and those are available as well. So what you choose would depend on your application. I should mention that if you have a brake, what the MOVIMOT usually does is it uses the brake coil itself as a braking resistor to dissipate regenerative energy. However, if you're using a brake controller, the brake controller may actually use an external brake resistor as well. As I say, this is rather complicated. There are a lot of options, but happily the MOVIMOT manual does lay everything out pretty clearly, and it shows you wiring diagrams for each possibility. We'll talk about this a little more in the next session. And that is the end of session 1. That was kind of a whirlwind tour of VFDs, MOVIMOT, the way it works, and all the accessories available. In our next session, we'll get into greater detail about the MOVIMOT itself, how you connect it up, how you set its control head, and how you get it ready to operate. So see you then.